Welcome to Sci-Fi Steve's Museum of Television and Movies, Rockets and Flying Saucers. First, I'd like to start by thanking Jack Haggerty and John C. Rogers for the book Spaceship Handbook, which gave me a lot of information about both ships, detailed specification and numbers, things like that. Today's tour was inspired by Rocky Jones, Space Ranger, and his rocket ship called the Orbit Jet, and then later on as things moved along it was called the SilverMoon. I don't know what Orbit Jet has to do with anything. Obviously somebody from personnel made up this name. It wasn't a jet, it was a legitimate rocket ship, didn't orbit anything in particular. It was often in deep space or had landed on its tail somewhere on a moon deep in space. The second rocket here is a rocket that I just really like from the era, and I was going to do a whole thing on it, but when I was all through mapping it out and looking for special products or things that I could put on it, I realized I'd put them all into the Orbit Jet. This is a rocket ship that was used in three good movies in the 50s, and the first was Flight to Mars, second was World Without End, and third was It, the Terror from Beyond Space. Now, I've decided not to do that, but I just wanted to give a special shout out to it here. Rocky Jones, Space Ranger. We're going to cover some of the high points of the ship right now. Overall length is approximately 135 feet. The shape of the ship, of course, is tapering at both ends, but at the widest point, it's just about 15 feet. The wingspan and the tails are almost identical, not quite, but they're roughly 50 foot across. Now, real quick, the Space Rangers are there to protect the united worlds of the solar system. And I only throw that out there because I go to sites as I was doing my research and I find these guys putting out there that Rocky Jones is speeding through the galaxy at the speed of light. And you're going, no, 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 no. That's not what this ship did. It's there to protect the planets of the solar system. And in Rocky Jones, a lot of the solar system was populated on moons. The Ophesians, who were the arch enemy, every time they'd go to plan a trip there, they'd go to this painting on the wall, and they'd point to Jupiter, and they'd point to one of the moons there. So they had a lot of extra planets with a lot of extra life on it, and they basically used the numerous moons throughout the solar system to populate them. Now, even though they talked several times that the ship was nuclear powered, they did some nice things for the kids. If they were going to go any long distance, they would dock at space stations that were set up throughout the solar system for refueling or repopulation of supplies that they needed. If they were going to go an extra long distance and could not stop at a space station, they would take the weight off the ship in the form of armament. Winkie got all upset when you take your missiles and weapons off the ship. The last two things, this is a single hull ship. It is a single stage to interplanetary travel. I usually mention that out, but that just adds to what this is. Okay, now with a little more detail, let's start with the nose. The nose has the high gain antenna. This is for communicating throughout the solar system, right? We'll even go into more detail on that later on. Next are the radar dishes. The two dishes that point sideways actually rotate around so you can get a 360 view completely around the ship. Now the gold area that you see next are the atomic batteries. And we went over this a little bit more in the UFO saucer, but basically we've had nuclear batteries since Voyager went out into space, and as you know, it's still running, right? These are high voltage, low amperage type battery systems, but they're very long. This is your survival system. If you have to eject the lower half of the ship and are going to be doomed to float around a planet or in space, you want to give yourself as much time as possible, and that's what these battery systems are going to do. Next comes the missile bay. It's a revolver type, that is, it rotates around, moving each missile into a launch position. Launching opens up a bay door, it jettisons it out magnetically, It ignites after it's free of the ship. Okay, these are very long-range missiles. They are certainly self-guiding, or you can control them. They're either ship to ship or ship to ground. Next comes air and water. You can see the two sets of spheres there. They contain the air and water under high pressure. The silver area right down below it are the scrubbers. The scrubbers are almost 100%. It'll allow you to stay in space for a very, very long time. If long-term survival is what needed, this system will give it to you. So for me, the next thing is the three decks in the storage area. Now on the show, they had long single deck that ran the length of the ship up and down, and you went from room to room via doors that would squeak open and squeak close. That means that you're walking sideways when you're on a planet. Now, they even mentioned that they had artificial gravity to hold your feet and stuff like that. No. To have artificial gravity, you not only have to be able to attract objects, but you have to prevent that gravitational energy that from going outside the hull of the ship. Otherwise, you're just the planet Earth flying around. You're going to pull things out of orbit. That's not going to work. So I made my decks horizontal, the three of them. You go up and down via the ladder on the side of the ship like that. I didn't do a Captain Nemo ladder up the center for space reasons. Now, if anybody remembers the show, and one of the things about the show is when the ship was going planet to planet, they always ran with the engine on. I don't know if they knew what they were doing, but basically that implies a continuous acceleration of the ship, which is wonderful because that's how we're thinking long travel is going to be done. So if you're standing on a deck and your ship is accelerating at a half G or 1G, for you standing on the deck, it feels like you're standing on 1G or half G planet because the floor is coming up to you continuously, and it gives you the sensation of gravity. You let go of an object, it doesn't fall, the floor comes up to you. That's why we did it this way. Now the four decks and their purpose. The top deck is the control center. That's the bridge. I have a real nice bridge all laid out. The center one is the lounge that you saw, and that's where they had the recliner chairs and stuff like that. One for Vienna, one for Bobby, and so the center deck is where I set it up. So the Professor Newton, because I liked him best, has a whole lab, and he can do all kinds of testing and work down there and figure out problems and things. The third level is the sleeping area. This is where you store your personal items for yourself, your personal spacesuit. This also has the shower and the toilet, things like that. It is also the airlock to the outside, like that. Everybody that comes on the ship has to have a spacesuit unique to them and set up for them, right? Just in case there's ever an air leak or anything like that. You just do. And then the bottom section, which I have sort of just blocked out in brown, that's just storage. And there's not really much more to say about that. If you notice looking at the drawing there, just to the left of center, there's some horizontal bars. That's actually your ladder. You climb up to the top, you climb down to the bottom. Every deck has a sliding type hatch. Okay, moving on down, let's start by taking a look at the wings. You notice there's a little gold strip on the forward edge of the wings, and that's the radar sensing devices. You want to know when you're getting tracked by somebody, and the ship will pick up the sense there, give that to the computer on board, and then you can set up countermeasures if they're needed. Also on the defensive side, at the wingtips, you notice that a mag rail gun has been set up. I like the mag rail gun. I think it will be the gun of the future. Its big deal is it shoots super high velocity projectiles that are typically armor piercing. Goes right through anything. No explosive devices are needed to make that go. If you take a look at it, we got the capacitor set up. We got the ammunition box all set up there. Next on the wing, those vertical gray tubes there, those are part of the cooling system for the reactor. The water goes through, and of course you want to cool the reactor water quickly, so you want to run it out to there. And if you take a look, in the center, you can see where the hot water pipes out. It can go in either direction. You can cut off one side or the other, right, and then bring the water back. There are two turbines. One's a backup. You need the voltage. We need the voltage for the system we're using for the engines. And then directly before that, below that rather, is the reactor itself. And down at the bottom, you'll find the engines. And the engines are the big breakthrough for this particular rocket. They're called VSIMR, and we'll get into what that is a little bit later. But basically, these are electric engines. Um, Not really nuclear in the sense that there's no radioactivity, no nuclear fuel being used at this end. It takes the fuel from the tanks and electronically, through high voltage, converts it into a plasma, thus giving us our forward thrust that we need. Now, also down here, what you're looking at is coolers for it on each side, similar to the coolers for the big engine or the nuclear reactor up above. These things run hot, very hot, but we'll get into that. I'll make a little note as you're looking at the bottom of the ship here, just above the engines and attached to the outside hull of the ship, you'll notice a series of spheres. These contain the fuel for the cooling units, and we'll get into the cooling units in just a little bit, but these are the fuel for the cooling units, and it's very necessary. Now this is the engine itself, and of course you can see the bell-shaped housing at the bottom, and at the top is the fuel intake and things like that. And right here I have it surrounded in a cold jacket, and this is for the refrigeration that I showed you, and it helps to keep the cold in. It helps to keep the unit overall um, cooled down. Now this is the same picture and perspective of the engine as the previous one, except that I've taken the cold jacket off, and what you're looking at are the coils that surround the entire engine, and that's all part of the chilling system, the part that keeps it cold, keeps those temperatures down so you don't end up with metal fatigue. If you get metal fatigue, it breaks down. If it breaks down, the engine's not running. Now, the other thing I want you to notice here is on the smaller end, not the exhaust, but the other end of the exhaust, there are a series of copper boxes that wrap around the engine. Those boxes are critical to the operation of the engine, as they are the RF box controllers, radio frequencies, and that is insight into how you heat the fuel. This is the cooling box you see at the narrow end of the engine. We're going to show you how it works and what it does. You'll see this box attached around each one of the engines, and it is the sub-zero refrigeration unit, and it will keep the engines very cold in spite of all the heat that they're generating to fly the ship. Now you put this on here to increase the longevity of the engines, right? The accuracy of the heat that you're creating and stuff like that, and the thrust. And you really need this to make this go. Okay. Um, I patterned this after the units that went on Hubble and on Chandler, right? So it's somewhat accurate as far as overall size and everything like that. And I attach one to each engine. This requires fuel. And just a quick reminder, remember I told you about the small spheres that were attached to the outside hull near the engines? Well, that is the fuel for these devices. And there are 10 spheres there to feed the fuel to these devices. The variable specific impulse magnoplasma rocket, sometimes referred to as an electrothermal plasma thruster or electrothermal magnoplasma rocket, uses radio waves to ionize and heat the propellant, then generate plasma that is accelerated using magnetic fields to generate thrust. Step 1, the solid propellant in a powder form is moved through the feeder and is prepped for the compression and ionization step. After the feeder and for the rest of the process, the fuel is confined via a magnetic field. Now, the first step here is the ionization, compression, and preheating of the fuel. The next step is to take the ionized fuel and heat it to plasma levels. Last step is to use the magnetic fields to accelerate and expand the plasma to create the maximum thrust we need. Now on the tail section, the upper and lower one, they're different from the side ones which have the coolers. You'll see that there are a total of 6 rear facing missiles, right? And these are to protect you from being approached from the rear, having missiles come up or somebody coming in behind you trying to shoot you down. And these aren't nearly the sophisticated missiles that you have up front. These will basically launch from the tail and go out heat-seeking wise and look for their target. They're designed to blow through a hull, things like that. No planetary attacks. Then you notice that there are 4 red semi-spherical balls. These are nets. That is, you fire it out and it opens up, spins around until it forms a net between 1 and 200 yards in diameter. Along the net are armor-piercing explosives, and the whole thing's made out of lightweight plastic and stuff like that, so that it can't be picked up on radar and allows the enemy simply to fly straight into them, right, and do them in. Okay, in the overall design, this is a military ship, and the goal, of course, is to keep the crew alive, even with combat conditions. The most catastrophic failure that could happen is the nuclear reactor. And I divided the ship into 2 sections. Basically, as you're looking at the ship, from the turbine pumps down and from the storage up is the division. You can jettison the lower half and the wings and survive for a very long time with the upper piece, because it has the batteries, it has the water, it has the refresh, it has your high gain antenna and radar. It has all the things for you to communicate and stay alive for a long period of time. Now, technically, there are some ways to land the upper portion of the ship, things like that, or just stay in space and floating around, right? But that's the goal. Now, how to enter the ship and exit the ship when it's landed. It always lands on its tail. There's no variation to a theme. Rocky would always say, let's exit the aft hatch. Now, that always presented itself as a hatch down near the engine compartment, and they would drop a ladder, and then you'd go up and down that. Now, the problem with that is we know that the gantry on Earth brought them in up near the top of the forward wing. Well, that's where the living quarters were. You have all of the engine components below that. That means you have to go from the upper area to the lower area, which makes you crawl through or get by the nuclear reactor. Now, I assume you're going to have a tunnel with a ladder, something large enough to accommodate a spacesuit, and all the shielding it will take to keep you alive going by the nuclear reactor. Plus, you have to take all that space out of your fuel supply and degrade the amount of area you have for your rocket engines. This is totally unsatisfactory. There was the one that Destination Moon did where they projected a ladder out from the side of the ship and you went down. The problem with that is, as the ship curves in, gravity is going to try and pull you away from the ship. Anyway, I came up with this method I'll show you now. Now, as you look at the ship, you go up to about where the entry would be if you brought up the gantry, which is just up towards the upper end of the wings. Now, you'll watch slide out like a CD tray, right? And basically, that's two 8-inch supports, and it supports a flat platform, which is about 5.5 feet by 5.5 feet. It is supported by 4 cables at each corner. It'll drop down to the bottom of the entry door. That door will open. You step out. 5 arms will actually lift up into position, so you'll have something to hold on to. And that will then drop down all the way to the ground. Now, the nice part is I use large cable systems and stuff like that. It's almost a 1/2-inch cable. This thing should easily be able to carry up to the entry level of the ship 3 to 5 tons on Earth, right? Having done some work with lifting engines and stuff like that on the car, this is no problem for that with a cable system. 4 cables, 4 motors. And now we'll walk up to the platform and see how this works. Finally, let's back onto the platform, right up to the sleeping quarters, and start the tour of the inside. When you first enter the ship, you're at the sleeping quarters. Just to the right, you can see the bunks, but straight ahead right now are the lockers. Everybody has use of the lockers. Primarily, you'll put your spacesuit in there, but any personal items that you may need or want, extra clothing, stuff like that, books, food items, anything like that that's personal to you, you put in your locker. The sleeping quarters have access to the cargo bay, which is located right below. This is that cargo bay door right here on the floor. The yellow stripes are there so that when you remove the door and set it aside, people notice that there's an opening, won't fall into it. There are 4 heavy latches. You have to lift all 4 heavy latches before you can lift the door out. And that's so that when it's put back into place, it becomes airtight. Okay, it's not necessary to be airtight for the room to be used, but it's a safety feature. This is the airlock control panel. There is one on each floor. It's located right at the ladder. You have a selector switch which tells you which floor you're doing your controls for. These can also open the outside doors and close the outside doors. It controls the slider doors between each floor. So as we look up in just a few seconds, you'll see those sliding doors. But this controls them, one on each floor, and they can control the other floors. To your right is the shower toilet combination, and directly forward is the airlock door, the one we originally came in. Of course, sleeping quarters would be incomplete without bunks. You got 3 bunks here. You figure a 24-hour cycle, you could put 3 men in the bunk every 8 hours. You have the blinds which move around and close the room off, so your bunks can have a certain amount of privacy. Down below, as you can see, there are 2 main boxes there. Those are for cleaning your clothes. Chances are you're not going to bring enough clothes with you for a round trip. Some of them are going to have to be cleaned, like your tidy whities. You put them in the 2 compartments down there. They're electronically cleaned or gas cleaned, but I'm quite confident they do not use water. This is Professor Newton's lab on the lounge level. Here, he and Vienna, sometimes even Bobby, work out complex measurements and observations of the solar system. These lockers are different from the ones down below. These are for the lounge, and they will contain such things as defibrillators, band-aids, splints, anything it takes for medical assistance that may be needed during the flight, because things like that do happen when you fly, as a space ranger. Also, the passengers can bring their personal access devices, monitors, things like that they like to use, pads. Even though we never saw them in the show, we know that by this point in time, these kind of things will exist. To bring your whole computer with you would not be unheard of. Here we have some more lockers, same as before. We have a couple of lounge chairs, a gaming table between the two sets of chairs. Um, I don't show it here, but I actually rigged them so that the legs will come up, the head will go down, it'll come at a right angle, things like that. Why? Because it's fun to do. Then we have the refrigerator, which large refrigerator you see there on top are two food preparation devices. Depending on the type of food, I imagine one would be like a radar oven, the other one would be something else in the future. Alrighty then, welcome to the bridge, and this is the reason most of you came. This is where the flight control systems are. Okay, as you can see, we have a nice array of panels and everything like that. Each panel does assorted things. We're going to go from right to left for no particular reason, as that's where the first one was when it came up the ladder. The first panel on the right is the nuclear reactor and the electrical systems of the ship, including backup. At the top, you see the gauges. From left to right there, the first gauge is the reactor. Next gauge, the heat exchange. Next gauge, the boiler. Then you have the two turbines. I remember one's a backup, but they both run all the time. So there is no lapse in power for the ship if one fails or becomes degraded. Then, the last control gauge on the right is the cooler. You can see directly below these dials are toggle switches and everything like that, and they're lined out so that each one pertains to a particular device for control. And that would be, let's say, the first four buttons there, toggles up and down. The reactor, next to heat exchange, next to the boiler, last to a cooler. On the right, auxiliary power systems. 8 knobs for the turbines. Okay, we got status control lights. Down below, we have additional controls for the heat exchange, the boiler, turbines. We got the amount of amperages being pulled out. We have the battery backup systems. Notice the keypad there. That's a combination keypad and function keys. This allows you to run diagnostics at any time while the system is up or down. It also can be used to control startup. For instance, you might control startup 001. You want a standard startup or standard shutdown. You can do either of those that you please, or any number of tests that may be done at any time. Moving around to the left, the next panel is sensors. This allows the ship to take a look at objects or anomalies around the ship, which could include enemy aircraft that need to be identified. Let's start with the bottom there. We have 4 large knobs which can be used to scan XYZ coordinates plus depth of field. The rotating periscope thing there, I figure the ship is going to probably have between 2 and 4 optical telescopes that can be activated and he can use to look through here. The pad up there can be used to set the electronic EM spectrum, right, to run specific diagnostics and or observations. The row of buttons there are filters. Pushing the button turns it on. Leaving the button off leaves it off. That little looks like a cursor control. That allows you to widen and shorten the spectrum that you may be looking at. Next, the 5 switches there are for the 5 visual spectrums that you can put up there. As you can see, we have 2 are activated, 1 and 2 are active. The lights are on, and what it shows is the molecular breakdown of the object that they're looking at. It could be the hull components, or it could be looking at a meteor or an asteroid traveling through the system. The screen there, whatever he puts on his scope with the switches on the right, can be moved up to the screen so that it can be shared with the pilot. The next panel is for the operation of the engines and fore and aft radar, offensive and defensive systems. First, the upper panel is for the operation of the engines. There are 5 rows, 5 engines. Across the top you have thrust. You got temperature measurements within the engine in 3 locations. If you take a look closely, there are 3 needles. Each needle represents the temperature as it is in a particular location of the engine. Next is the magnetic field and confinement, right? Third is the last 2 are the RF1 and RF2. Remember, radio frequencies are used to bring the material up to the temperatures needed. Okay, then you have minor adjustments on the dials associated with that gauge. Next, on the bottom, you have the refrigeration units. That is, the refrigeration units, there are 5 of them, 1 for each engine. And then the last, which is actually a dial there to the right, gives you the amount of coolant fluid that is left. On the lower panel, you have fore and aft radar system, so that you can see forward and aft what's going on, stuff like that. The red gauge is called optical tracking. It is used for tracking objects specifically. Now, from there, you got the toggle switches, which can allow you to manually trace an object, which has to do then with the joystick. You can move the object on there to the attack screen on the lower or middle left. Okay. To the right immediately, you have programs. You can auto-program the type of offense or defense that you need. You can also run diagnostics, very important. Weapon system, fore and aft, right? You got standby. Basically, standby unlocks the mechanism so that launching can take place. You get it ready. You want to do auto tracking or non-auto tracking, standard or tactical weapon explosion. Now, that doesn't apply to aft. If you go aft, the auto doesn't have any meaning. The standard or tactical has no meaning. You basically just launch it. It follows its own, right? The next set of things is mag guns. Those are the ones that were on the wing. Same sort of thing. Standby, ready, auto, fire. Next is the forward screen. But for those who knew and loved the show, it was called Visiograph. Visiograph had the ability to peer through buildings, stone buildings, steel buildings, could penetrate in any number of rooms and actually watch and listen to what went on there. Okay, now for me to make that work, if you notice the controls underneath there, those are for all kinds of different densities of walls, fluids, controls, and stuff like that that you would want to set up as filters to pick up objects within there. And then below there would location, XYZ location, because you're going to have to dial in a specific place. We have a program there. You can run programs if you've done this kind of thing before, if you know what it is you're looking at. Okay, and these all control Visiograph. Now, just to the right of the XYZ coordinates, you'll find a dial for PA, EVA, ship, so on. This is your ship communication. PA, public address. EVA, any crew member currently outside the ship. Now, that could be more than just in a spacesuit. They could be out visiting their cousin. And you want to dial them in and say, hey, come on back. Okay. Just below the programs there, you will find a card reader. This is where you would punch in and download to the system anything special that you needed, which could include, let's say, flight plans. Let's say you were on a secret mission, not to be told to anybody. You'd come in here, you'd drop it in there, and you would put that into the ship system, and he would control the flight. Just a computer display of lights and a keyboard in case you wanted to type, override, or anything like that. Left or right of the computer lights are microphones. Okay, next panel top starts with the environmental systems within the ship. You have 3 decks, 3 sets of dial, air pressure, oxygen, CO2 levels, things like that. You have below them controls to increase flow, decrease flow, things like that. Switches which would control um, subtleties that you may want to do to a particular level. Just below that are the flight controls. The flight controls now are different for in space and for in the atmosphere. Notice the large horizon gimbal. Well, you're going to need that if you're in the atmosphere. You have no windows to look out. And the velocity, you could be accelerating at a speed that would prevent you from feeling what direction gravity's in. The dials to the left would give you like altitude, atmosphere pressure, skin temperature, stuff like that. The gauge just to the right of the horizon gimbal is your speed, whether you're in space or in the atmosphere. To the right, you're in space, and it would give you general gimbals from with your current flight path for the direction that you're headed. Okay. Down below, you got some switches. You can throw some filters into the situation to get it all going. Down below that, these 3 gauges here would show the ship and small dials associated with them. They have those very long descents. Remember, they used to read off altitude as they drop down. And that's what these are for. You can set up the descent vectors and things like that to help control that, so it's not so manual. Just below there are larger gauges for bigger and bigger moves. And to the right is the thrust control. Now this is in percentage, not tons of pressure or anything like that, or velocity. This is how much thrust you're going to throw out of your engines, and then you can watch your gauges to see if your descent is behaving the way you want it to. Now, this can be overridden by the pilot's chair, and we'll look at that because it's a flight control stick, and on there is a throttle control also. And supposedly as you move that in, this will move up and down to match it so that they're always in sync. Navigation. I have high hopes that by when I see Rocky Jones flying around, um, planetary positioning will be done by satellites just as we do GPS here on Earth. There will be celestial position sensitivities. There will be a lot of satellites, space stations, um, both on the eclectic plane and then in a cross section to the eclectic plane. And you will dial in these satellites and they will tell you exactly where you are, probably within a meter or two, because that's what we're doing on here on Earth, right? So you notice I have the gauges called celestial PS, position sensor. I have orbital PS, which celestial PS doesn't make much sense because you're at a planet, but you would want to know your apogee and perigee, your speed, whether or not you're on an equator orbit or if you're doing a polar orbit, things like that. And this gives you all that information very accurately. To allow the pilot and co-pilot to stay on the bridge at all times, they have their own lockers and food preparation units. Okay, the last big item on the bridge are the chairs. Let's bring the chairs in. These chairs will rotate onto the back for blast off. In the upright position, you can see that there's a joystick. That's for dogfighting. You can actually fire the weapons from there, things like that. You can see the little buttons. And it's plenty cushy, because if I had to fly it, I'd want to be comfortable. I want to thank you for your time. I hope you enjoyed all the drawings. And that concludes our tour of Rocky Jones' SilverMoon.